Alright, so this video, let's take a look at the law of sines and law of cosines. Now in a trig class, typically this is split up into two, maybe three sections. Okay, I've seen it split up into two sections in some books, three sections in others. I decided to do one video on everything, okay, because it just goes together. And I think it's easier for you to understand if you can see it all in one video. I would encourage you to watch the whole video, and I really believe if you watch the whole video, you'll understand it. Okay? And, if the video helps, give me a like, share it, and subscribe. All right, so let's go ahead and get started. So we've got the law of sines, law of cosines. So for the law of sines, it says sine alpha over A is equal to sine beta over B is equal to sine, this is gamma, okay, over C. And you can see side A is opposite alpha, side B is opposite beta, and side C is opposite gamma. All right, so what this means right here is you can take any one of these two and set them equal to each other. You can set this one equal to this one. You can set this equal to this, or you can set this one equal to the last one over here. Okay, just pick them. See which ones you need to set equal to each other. And I'm going to show you how to do that while we're working the examples. Okay, and then we have the law of cosines. We've got, I'm not going to read them all. Let's just look at the first one. A squared is equal to b squared plus c squared minus 2bc times the cosine of alpha. Now, don't memorize all of them. Okay, just memorize the first one. If you know this first one here, you can get the other ones because they're all the same pattern. You see a squared right here. And this angle is the side. This side is opposite this angle. See, this side is opposite this angle. This side is opposite this angle. Okay? And so once you have this, then it's just the other two sides squared. You're adding them together minus 2 times the other two sides. And that's all it is. Okay, so just remember the pattern of it. Don't try to remember, each one. Because if you know the pattern, then you can get them. All right. Now, the other thing that you see in these, in the textbooks, is you see the side, angle, angle, side, angle, side, angle, side, angle, side, 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 all that. And they list all the cases and everything. And, that's just something more for you to memorize. I don't even use that stuff. Okay, I'm going to show you how to solve these things where you don't need to memorize all that stuff. Okay. All right. So before we get started, okay, let's just think of this as one thing. We're solving triangles. We don't know, do we use the law of sines? Do we use the law of cosines? Okay, we're going to figure it out while we're working the problems, and I'm going to show you how to do that. All right. So what you want to do is whenever you're solving a triangle, okay, whenever you're solving a triangle, never, ever use the law of cosines. Okay? Never use the law of cosines. Now you probably might be thinking, well then why do we have the law of cosines if I never use it? All right, so let me finish the statement. Never use the law of cosines unless you have to. Okay? That's how you want to think about going into these problems. Okay? So we're not going to use the law of cosines ever unless we have to, unless we're forced to use it. All right, so let's go ahead and get started. Now, the examples that I'm going to work, I got some examples, and if you watch this whole video, it's hitting everything that you'll come across. Okay, I'm gonna cover every scenario that you'll come across. So let's solve the triangle. So what I like to do when I'm solving these things is I like to make a table. Angles and sides. And so I've got alpha is 32 degrees. Beta is 81.8 degrees. Gamma, we don't know. A is 42.9. B, we don't know that. And C, we don't know that. All right. So there you go. If you draw this table out on all of them, it tells you how to solve it. Okay. So if you look at this, do you see how we know alpha, A, and beta? Well, let's look at this. We know alpha, A, and beta. Look, we can solve for B. You see that? And we can get what B is. All right? So there you go. That's the law of sines. You see, that table lets you see it. Okay? The table lets you see what you can use. All right, and then also for gamma, we don't know gamma. I mean, yeah, we're going to solve for B, but let's go ahead and find gamma first. All right, let's just find it first. So gamma is equal to what? 180 minus 32 minus 81.8. Now, how do I know that? How do I know that's what gamma is? Well, because we know that all the angles of a triangle add up to 180 degrees. So if I do 180 minus this angle, that's going to tell me what this is. So I am going to get gamma is equal to 66.2 degrees. So that's 66.2 degrees. Yep, 66. I just had to check myself real quick. All right. So we got that taken care of. Do you have to solve for gamma first? No, I just did. Okay. Now let's solve for side B. All right. So that's going to be what? Sine alpha over A equals sine beta over B. Okay, and now we solve for B. All right, so remember, whenever you're solving, you got this equals here. We got fraction equals a fraction. So remember, when you move it across the equal sign, if it's in the denominator, it goes to the numerator. So I'm going to move B across, so that's going to pop up into the numerator. When I move the 42.9 across, that's going up into the numerator. So that's going to be 42.9 times sine of 81.8. And then when I move sine 32 across, that's going in the denominator. Sine 32. Oops. And so that is going to give me side B is 80.1. So that's 80.1. There you go. Now, let's solve for side C. Now remember, you cannot use Pythagorean theorem here because we don't have a right triangle. Okay? We don't have a right triangle, so Pythagorean theorem, you can't use it. So we got to solve for C. So look at this. We've got gamma. We don't know C, but we know alpha and we know A. So I can do it just like I did this one. You see that? Except I'm going to use gamma and C instead of beta and B. Now, you might be thinking, well, couldn't we use beta and B? Yeah, you can use beta and B. You can use sine beta over B equals sine gamma over C. All right? And that would be correct to do it like that. But you don't want to. Why don't you want to do it like that? Well, Like I said, it's not wrong to do it like that. But just remember, this number here, 80.1, was calculated. Okay, we calculated that number, punched it in our calculator and wrote the answer down. This value here is rounded. Okay, it's rounded. And then the other thing that we think about is, what if I put it in my calculator wrong? What if I hit the wrong button in my calculator? Then that means this value is not correct. So that means if I use this to get C, then C is going to be wrong also. So why use alpha and A? Because alpha and A, I know those are right. That was given. So whenever you're solving these triangles, try to use given information. Try not to use information that you calculated. Now, I understand, I know in some instances, you have no choice. You're going to have to use values that you calculated. But if you can avoid it, then avoid it. Okay? Like this value here, 66.2 degrees. We calculated that value right here. But I have no choice. I have to use it. Okay? And the chances of this being incorrect is highly unlikely. I mean, yes, I could have punched it in wrong, but one thing we know about this angle here, it's not rounded like this one. Okay? All right. So let's use alpha and A, gamma to get C. So I've got sine of 32 degrees over A, which is 42.9, equals the sine of gamma, which is 66.2 over C. And then I solve for C. So C is equal to 42.9 times the sine of 66.2 over the sine of 32. And what do I get for that? I get 74.1. And this is your answer. That's your angle. That's your triangle solved. All right? Like I said, stay with me. All right? Watch the whole video. If you watch this video, you're going to know how to work this stuff. All right, next problem. Same thing. Let's make out a table. So I've got angles. I've got sides. So alpha, well, I don't know that. Beta is 55.7. Gamma, we don't know. A is 25.1. B is 8.94. And C, we don't know. All right. So looking at the table, what are we solving for? We're going to solve for alpha. See, we know beta, B, and A. That just leaves alpha unknown. See, that's sine alpha over A equals sine beta over B. And we know three of them. This is the one we'll solve for. You see how easy the table makes it once you write this table out? All right. So I've got sine alpha over A equals sine beta, which is 55.7, over B, 8.94. So I get sine alpha is equal to 25.1 times the sine of 55.7 over 8.94. And so what does that give me? That gives me sine alpha is equal to 2.3184,379. Okay, so there's sine alpha. So now I need to find alpha. Well, this, no triangle possible. Oh, well, how did I know that? Okay, how did I know that? Well, think about all the stuff that you've learned in trig. Okay, think way back, all that stuff you've learned. Whenever you take the sine or cosine of an angle, your answer is going to be between 1 and -1. Remember? Here's the graph of sine. See, these are your angle measures here. See, 180, 360, 0, and so on. Well, look, the value that I'm going to get out is never above 1 and never below. That should come down to -1 and never below -1. So you see this 2.3? That's up here somewhere. That can't happen. Okay, it can't happen. I got sine alpha equals something more than 1. That's not possible. Or if I got sine alpha equals something down here below -1, that's not possible either. So you might be thinking, well, how would I know? What if I forget that? What if I forget it? Okay, big deal. So you forget it. All right, do the inverse sine. Remember that? Remember the inverse sine in your calculator? It's right up above the sine button. Do second sine, and then just type in 2.3. Don't even worry about typing in the whole thing. Just type in 2.3 and hit equals. And what does your calculator say? Domain error. It's not possible. So this, no triangle possible. All right? All right, let's go to the next one. All right, so let's see what we've got here. All right, so I was copying these down. I wrote a capital A. You can do that, capital A for your angle. Let's just change it to alpha so we're consistent throughout the video. All right, so let's do the table again. Angles, sides. So I got alpha is 55.3 degrees. Beta, we don't know. Gamma, we don't know. A, we get 22.8. B is 24.9. And C, we don't know. All right, so here we go. What are we solving for? Can you tell now from looking at the table what we have to solve for? We're solving for B. You see that? We're solving for B first. All right, so let's do that. So I've got sine of 55.3 over 22.8 equals sine, and I think I said B, I meant beta, same thing. All right, so that's going to give me sine beta is equal to, so the 24.9 comes up here, 24.9 times the sine of 55.3 over 22.8. And so that's going to give me sine beta is equal to 0.8978 and so beta is equal to what? 63.9 degrees. All right, so you might be wondering, well, how did you get the 63.9? Well, I did this. Beta is equal to the inverse sine of 0.8978678. That's what I punched in my calculator, this right here. All right, you take the inverse sine of this number to get your angle. All right. So that's what we get. All right. So let's hang on just a second here before we move on in the problem. So I've got sine beta is equal to what? Sine beta is equal to positive 0.89 and some decimals. But the key here, the important thing, sine is equal to a positive. A positive. Now, isn't sine positive in the first and second quadrant? All right. Now, it's positive in the first quadrant. There's my first quadrant angle. But it's also positive in the second quadrant angle. In the second quadrant. Now, the second quadrant is between what? 90 and 180 degrees, right? Well, is it possible to have an angle measure of a triangle? Like if we have a triangle, is it possible for one of these angle measures to be between 90 and 180 degrees? Of course it is, right? It can't be more than 180. Like one of these angles can't be more than 180 because all the angles add up to 180. If we wanted to, this could be 179.9 degrees. It's just that this angle and this angle would add up to what? 0.1. You see that? If I added this angle and added this angle, that would equal 0.1 because everything adds up to 180. All right. Wouldn't look like a very good triangle, but it's still a triangle. All right. So sine beta is positive in the first and second quadrant. So what that means is we have a possibility of two triangles as our solution. Okay, we've got a possibility of two triangles being our solution. Now, key word there, possibility. Okay, possibility. So let's see. So there's my second quadrant angle, right? There's beta, and I'm going to call that beta with a subscript 2 to show that it's different from this beta. Now, remember reference angles. Here's my reference angle, 63.9 degrees. So that means beta 2 would be 180 minus 63.9 degrees, and that equals 116.1 degrees. There's beta 2. Now, my question to you is that going to work? Can that triangle work if beta is 116? Well, let's see. So I've got beta 63.9. This is 63.9. We know this is going to be a solution, this triangle right here, this first one. But will the second one work? That's what I want to know. All right. Well, the given angle is 55.3 degrees, right? That's our given angle. So we know that's an angle measure in the triangle. And if I add that to 116.1, what do I get? 55.3 plus 55.3 plus 116.1, that is equal to 171.4. Is this less than 180? Yes. So that means we have a second triangle. Now, if that doesn't make sense to you right now, okay, if that doesn't make sense to you right now, finish watching me work this problem, and then watch me work the second problem, the next problem. It's going to be like this one with the possibility of a second triangle, but that second triangle's not going to work. And I think if you see that, then it'll all make sense. Okay? All right, so we've got two triangles as a solution. All right? All right, so let's make another table. Angles, sides. All right, so I've got alpha is 55.3. Now this is beta 2 is 116.1. So I tell you what, since we're gonna label this one, hang on, since we're labeling these like beta 2, gamma 2, C2, let's come over here and label these beta 1, gamma 1, and C1 since we have two triangles. All right. So there's our two triangles. And look, and don't worry, you know, I know you might be thinking, well, how do I know when to check for two triangles? I'm going to explain that. Okay. I'm going to explain it. Let me finish working this one and this problem, and then I'll explain how you know when to check. Okay. I have to go refer back to the first problem we did. All right. All right. So we've got all this. Now just solve both triangles. Solve both triangles now, just like we did before. Okay. All right. So let's find gamma 1. Gamma 1 is what? 180 minus 55.3 minus 63.9, and that is 60.8. So that's 60.8 degrees. And then let's go ahead and find gamma 2 while we're at it. So that's 180 minus 55.3 minus 116.1. And that is going to be, let's see, 8.6 degrees. Now, remember how I showed you, okay, is there a possibility of two triangles? And I showed you how if I add the 116 and the 55, add that together, and that was less than 180. If that doesn't make sense, see if this makes sense. So we check for the possibility of two triangles. Okay, so there's a possibility of two triangles, and you might not be sure of how I know when to check, but like I said, I'm going to explain that after I get finished with this problem. I promise. All right. So let's say that we go ahead and set this table up. Okay. Well, I think we've got two triangles. Let's set it up. So when I go to find gamma 2, when I do 180 minus 55.3 and minus 116.1, do you see how I got 8.6? That's that angle. Now, if I would have done 180 minus this angle and minus this angle, and this would have been a negative number, then that wouldn't have been two triangles. The second triangle would not have been possible. Or wouldn't, well, there's no second triangle. Okay? But like I said, if that's still not making sense, just hang on until we get to the next problem. All right, so now let's find C1 and C2. So look, I'm going to use alpha and A, gamma 1 and C1 to find C1. All right, so this is going to be sine of 55.3 over 22.8 equals the sine of gamma 1, which is 60.8, over C1. So C1 is 22.8 times the sine of 60.8 over the sine of 55.3. And let's see what that gives us. That gives us 24.2. There you go. There's your first triangle. Now let's find the second. So I'm going to use alpha and A again, and then gamma and C2. So that's going to give me sine of 55.3 over 22.8 equals the sine of gamma 2, which is 8.6, over C2. And so I get C2 is, what is that? 22.8 times the sine of 8.6 over the sine of 55.3. And that gives me 4.15. And so that's going to be 4.15 or 4.2. I mean, I don't know, however many decimal places your teacher wants you to round to. Okay, ask them how many decimal places to take it out to. If you're in my class, I don't care if you get 4.2 or 4.15. I'm happy. You get the answer right, I'm happy. I'm not really that big on what you round it to. Okay. All right, so there's your solutions. There's your two triangles. All right, so now the question we had earlier, how do I know when to check for two triangles? Okay, because look, up here in this first problem, I didn't even mention checking for two triangles, did I? Didn't even mention it. Why not? All right, so let's look. Well, if you look at this, they gave us these two angles. You see that? Those two angles were given. This can't be anything else but 66.2 degrees. There's no way there's two triangles possible. I mean, what else is it going to be? Because this angle has to be 180 minus this one, minus this one. There it is. We have no choice, no options here, because these two angles are set. See, if they give you the angle 32, and I'm just going to put 81, this can't be anything but that. Okay? Can't be anything but 66.2 because these angles here are set. And then, of course, this one, well, what else was I going to do? There's no triangle. Okay? There's nothing else you can look at. So this one, when you check for two triangles, okay, when you check for two triangles, do you see how I'm given one angle and two sides? You see how two angles are unknown? That's when you check for two triangles. When you have the two angles unknown and you're given one angle, then you check for two triangles. Now I'm going to add a little more to that, okay, later on when we get to the law of cosines. I've got one more example with the law of sines, and then we've got two examples with the law of cosines. And I'm going to talk a little bit more about this to just make it even easier on you when you need to check for two triangles. All right? All right, so hopefully you understand that. If you're given one angle and two angles are unknown, you check for two triangles. All right? Now, I'm telling you right now, if you stop watching the video and don't hear the rest of that, then you're going to struggle. Okay? You need to watch the rest of the video because I'm going to make some more clarification on that. All right? Because it's not necessarily that. There's another condition that goes along with this. Okay? Of one angle given and two unknown. There's a little more I got to add to it for it to be true. Okay? But for right now, all we know is the law of sines. We don't know the law of cosines yet. We haven't worked any of those problems. All right. So let's look at this one. And then there I go again. I put A. Let's change it back to alpha. Look, I mean, even if this was A, everything still worked the same way. All right, so I get alpha is 43.5. Beta, we don't know. Gamma, we don't know. A is 10.7. B, we don't know. C is 7.2. All right, so how about this problem? Well, we got the table set up. I know alpha and A, right? I know alpha and A. I'll solve for gamma because I know C. I know alpha, A, and C, so I can solve for gamma. So I get sine of 43.5 over 10.7 equals the sine of gamma over 7.2. So I get sine gamma is equal to 7.2 times the sine of 43.5 over 10.7. And so that's going to give me sine gamma is equal to 0.46319,319,186. And so gamma, so I'm going to do just like in the last problem, the inverse sine of this. So I'm going to get gamma is 27.6 degrees. So I've got 27.6 degrees. There you go. Now remember what I told you. One angle's given, two are unknown. So there's a possibility. Remember, that's so important that you understand what I'm saying there. Possibility of two triangles. I didn't say there are two triangles. I said there's a possibility. All right. So let's find our angle in the second quadrant. Okay. So we'll call this gamma 2. There's our reference angle, 27.6. So I get gamma 2 is 180 minus 27.6, which is 152.4 degrees. That's gamma 2. So look at this, 152.4 degrees. So if I take the 152.4 degrees and I add the given angle to it, see, because that's given. That's an angle in the triangle. That's given. What does that equal? Well, that equals 195.9 degrees. You see that? The gamma 2 in the given angle is greater than 180 degrees. So the second triangle can't be possible. Does it make sense now? Do you understand what I was saying before? I mean, I'm sitting here asking you questions like you can respond to me, but do you get it now? Okay. That's what I was talking about when you had to check. All right. That's what I was talking about. And look, even if we did come up here and we had, and let's just say we did do a second table. Okay, I've got the 43.5 degrees, and down here for gamma I got, what was it, 152.4 degrees. There's alpha. Okay, so let's just say I did set up a second table. Okay, find beta 2. So beta 2 would be what? 180 minus 43.5 minus 152.4. All right, so put it in your calculator, see what you get. 180 minus 43.5 minus 152.4. That gives us negative 15.9 degrees. That's what I was talking about earlier. Okay, so go ahead and find, if you think there's two triangles, find that third angle. Angle of a triangle can't be negative, so you know that one's not possible. That's what I was talking about. And that's why I say there's a possibility of two triangles. All right? So now you've seen everything that you're going to come across with the law of sines. This is everything right here. I mean, we're going to finish solving this, but that's all the different scenarios there. Where there's one triangle like the first problem, and we didn't even have to check for a second triangle because two angles were given. And then we had no triangle. And then we had these two problems, this one and the one right before it, where there was a possibility of two triangles. Well, the problem before this, there were two triangles on we had the possibility, and this one we had a possibility, but the second one didn't work out. All right, so that's what I was talking about there. All right, now let's just go ahead and finish solving this one. So let's go ahead and get beta. And notice I'm not going to label it beta 1, gamma 1, B1 because, this is the only triangle. Okay, so that's what, 180 minus 43.5 minus 27.6. And that gives us 108.9 degrees. So that's 108.9 degrees. And now let's find side B. So obviously I'm going to use the given information, alpha and A. So I've got sine 43.5 over 10.7 equals the sine of 108.9 over B. And so B is 10.7 times the sine of 108.9 over the sine of 43.5. And so that's going to give me side B is 14.7. And this is your angle. I mean your triangle. Angle. It's your triangle. All right. Now, let's remember what we said at the very beginning of the video. Never, ever, ever, ever use the law of cosines. Remember when I said that? Never use the law of cosines unless you have to. Now, with that in mind, let's work the next example. And there I go. I don't know. I'm writing A down. All right. So let's do angles, sides. All right, so alpha is 42.3 degrees. Beta, well, we don't know that. Gamma, we don't know that. A, we don't know that. B is 12.9. C is 15.4. All right, so, well, look at this one. Can I use the law of sines? No, because I mean, look, if I pair these two up, I got two unknowns. If I pair the last one and the first one up, two unknowns. This one and the second one, two unknowns. So I can't use the law of sines. I have to use the law of cosines. All right. So what am I going to use? Well, let me go back up here and copy those formulas back down. All right, so here's what we've got. Now, what am I going to do? Well, see what I know? Alpha and B and C. Alpha, B, and C. So I can solve for A. You see that? Solve for A. Just look to see what you have. And then, plug the stuff in. That's all you got to do. I mean, I'm not going to use this one. I mean, I don't know. Could I? No, because look, well, let's see. I don't know A. You see that? If I tried to use this, I don't know A. And if I'm looking for beta, that would be two unknowns. So, see, alpha, B, C. See here, you've got to know everything. You've got to know everything to plug in but one of them in order to use it. So you can see it's this one. You see that? It's this one. All right. So let's do that. And what I'll do is I'll write down the formula again. I'm just going to erase all these, give myself a little more room. All right, so I'm solving for A first. So remember, that's A squared is equal to B squared plus C squared minus 2BC times cosine of alpha. All right, so I've got A squared equals 12.9 squared plus 15.4 squared minus 2 times 12.9 times 15.4 times cosine of 42.3 degrees. And so I get a squared is equal to 109.7 degrees. And so A is equal to 10.47. 10.47. There you go. Now, remember when I told you the possibility of two triangles, and I was going to add something else to it. Well, here it goes. And this is going to make all this so much easier. Remember, in the two problems we worked before this one, we had two angles that were unknown. We could use the law of sines. So we had to check for the possibility of two triangles. If you have to use the law of cosines first, okay? So if the first thing you have to do, see on this one we had no choice but to use the law of cosines. We had no choice. If you have no choice but to use the law of cosines first, you don't have to check for two triangles. There you go. So the only time you got to check for two triangles, the only time we're checking for two triangles is when we have two angles unknown and we're using the law of sines first. All right. So you see here we had to use the law of cosines, so there's not a possibility of two triangles. There you go. All right. So now we use the law of cosines to find A. Now, look, we can go back to the law of sines. Go back to the law of sines now. All right. So let's look at this. So the next question, do I need to solve for beta or gamma first? Which one do I need to solve for first? Or does it matter? Well, it matters. It'll be real difficult if you solve for gamma first instead of beta. We're going to solve for the smaller angle first. Now, see if you can follow this logic with me here. I'm going to try to do my best to explain to you why we're solving for the smaller angle first. Okay? So let's suppose we wanted to solve. Let's say we were going to solve for gamma first. So we get sine gamma is equal to, I don't know, what would that be? That would be sine gamma over c, so that would be 15.4 times sine of 42.3. Reason I'm not writing all this down because we're not going to solve for it first. I'm just trying to show you of why we don't. And so then I get sine gamma is equal to some number. And so gamma is equal to some angle measure, okay? Whatever angle measure that is, okay? Now, the one thing I want you, it's not important what it is exactly, okay? I'm trying to explain this to you. Just follow along. If you're falling asleep, stand up and do some jumping jacks, or it's something to wake yourself up so you can listen to this. All right. Now, gamma equals, now, you agree that when we do the inverse sine of whatever number this is, we're going to get an angle measure between 0 and 90 degrees. All right, it'll be between 0 and 90 degrees. How do you know that's what it is? How do you know this is between 0 and 90 degrees? How do we know it's not between 90 and 180? How do we know that? Because, we talked about that earlier, that an angle of a triangle could be between 90 and 180. That's possible. So how do we know that gamma is not between 90 and 180 or 0 and 90? Which one is it? It's one of them. It very well could be between 0 and 90, but we don't know that. Okay? We don't know that. Okay, just keep staying with me. Stay awake. Keep staying with me. All right. So that's why, and I'm going to explain some more. Just bear with me. So that's why I'm going to solve for beta first. I'm going to explain it some more. Just stay with me. So I get sine beta is equal to 12.9 times the sine of 42.3 degrees over 10.47. So I get sine beta is, what is sine beta? Let's see. Let me see. I'll put that in my calculator, I guess. 12.9 times sine of 42, sine 42.3 divided by 10.47. And so that is 0.8292133126. And so beta, if I do the inverse sine of that, that gives me, look, I'm just gonna, let's see, let me make sure I did. All right, so yeah, it's 56 and some decimals. I'm just gonna go ahead and round this to 56 degrees. So that's 56. Now, I know what you're probably thinking. Well, how do I know beta is between 0 and 90? How do I know that? How do I know it's not between 90 and 180? Well, I know it's not. And why is that? Because gamma is the largest angle in the triangle, right? Because it's opposite the longest side. You see that? I'm solving. So once you do this, I solve for the smaller angle first, because I know that the smaller angle is in the first quadrant. It's between 0 and 90. I don't know if this is between 0 and 90. It might, but I don't know that. It might be between 0 and 90. It might be between 90 and 180. But if I solve for beta first, I know when I go through this law of sines here and I take the inverse sine of this, I know when I punch that in my calculator, I'm going to get an angle in the first quadrant. I know that. And I know beta is in the first quadrant because it's not the largest angle. But when I go through the law of sines, if I did this with gamma and I go through the law of sines and I do the inverse sine of whatever, it's going to give me an angle in the first quadrant. But I don't know that gamma is in the first quadrant. It could be in the second because it's the largest angle. Okay, does that make sense? Just remember, when you have a triangle, you cannot have two angles in the second quadrant. You can't have two angles more than 90 degrees in a triangle. Okay, for instance, if beta was 91 degrees and gamma was 92 degrees, when you add those up, that's 183. That can't happen. Okay, so that's why we solve for the smaller one first, because we know it's in the first quadrant. Well, now I can solve for gamma. So gamma I know is 180. Is 180 minus 42.3 minus 56. And that ends up giving me what? 81.7 degrees. 81.7 degrees. Oh, well, look at that. Gamma was in the first quadrant. How about that? But guess what? If you would have solved for gamma first, you would have gotten it correct. But you would have gotten lucky. Okay? And that's like I said, when I was explaining all this, remember I said, and you can rewind the video, gamma could be in the first quadrant. It could be between 0 and 90. Or it could be between 90 and 180. But I don't know that. That's why I solve for the smaller one first, because I know beta is between 0 and 90. All right. So there's your solution. All right. So now we've got one more problem. This is the last one right here. All right. So let's go ahead and do this. We've got angles. We've got sides. There you go. Boom. There's alpha, beta, gamma. A is 9.47, B is 15.9, and C is 21.1. There you go. All right, so first thing we think of, use the law of sines. That's how you want to go through all these. Use the law of sines. But I can't. You see that? We can't. We have to use the law of cosines. We have to use the law of cosines. Now, what do I solve for first? Okay. Do I need to solve for the smallest angle, the largest angle, or does it matter? Honestly, it doesn't matter. Okay. I know what you're thinking. Well, why don't we just solve for the smallest one first? Yeah, you can do that. That's fine. That's fine. Solve for the smallest one first, then the next smallest, and then the largest. That's fine. But what I normally do, I mean, I've seen it written in books. They have all these procedures written out of, do this, 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 and this when you're solving using law of cosines. But I'm trying to get it to where I want you to understand why you're doing those steps. Okay, that's why I harp so much on this and explain to you why we're solving for the smaller one first. Okay, now this one, no, it doesn't matter. It doesn't matter. But what I'll normally do is I'll just solve for the largest one first. Okay, so let's solve for gamma. Just trust me right now, and then once we get gamma, I'll explain why it's okay to solve for the larger one first. So, because I want you to understand it. All right, so we're going to solve for gamma. All right, so we know which. Do you know what formula we're going to use? Well, that's going to be what? C squared is equal to A squared plus B squared minus 2AB times cosine gamma, because we know A, B, and C, don't we? Then we can get cosine gamma equals whatever. All right, so that's what? 21.1 squared equals 9.47 squared plus 15.9 squared minus 2 times 9.47 times 15.9 times cosine gamma. And so I get 21.1 squared minus 9.47 squared minus 15.9 squared equals negative 2 times 9.47 times 15.9 times cosine gamma. All I'm doing, I'm solving for cosine gamma, getting it on one side by itself. I subtracted this and this to both sides. All right, and then I'm going to divide both sides by negative 2 times 9.47 times 15.9. So that's going to give me cosine gamma is equal to 21.1 squared minus 9.47 squared minus 15.9 squared over negative 2 times 9.47 times 15.9. And so I get cosine gamma is equal to, negative 0.34109.402. So here we go. Now, let me explain to you why it doesn't make any difference. All right. So, when I solve for cosine gamma, I get this right here. Okay. Now, what I want you to agree on here is, can you agree with me that when I put this into my calculator, that I may get a positive or a negative answer? I mean, in this case, I got a negative. Okay. If I would have solved for cosine alpha and I, did all this stuff and solved for cosine alpha, I would have gotten a positive. All right. Same thing with beta. I would have gotten a positive. But I could get a positive or a negative. And look, and when you solve for the larger one first, you're not always going to get a negative. You may get a positive sometimes. It's just in this problem, we got a negative. Now, remember, when you do the inverse cosine, go back to when you learned about inverse trig functions. Remember, the inverse cosine is between 0 and 2 pi, or 0 and, 0 and pi, or 0 and 180. Okay? Remember, when you do the inverse cosine, remember when you did the inverse sine, that was between negative 90 and 90. Cosine was between 0 and 180, or 0 pi, whether you were looking at it in degrees or radians. All right? So if you remember, here's the first quadrant, here's the second quadrant. Cosine is negative in the second quadrant, and it's positive in the first quadrant, right? For cosine. So what do you think if I do the inverse cosine of this? This is negative. I'm going to get that second quadrant angle. See, it's going to tell me. I don't have to worry about it like I did in the previous problem, because I was using the law of sines in the previous problem. I'm using the law of cosines here. So I know when I solve for that largest angle, when I do cosine of that largest angle equals, if I get a negative, that's going to give me the second quadrant angle. You see that? All right, so I hope that made sense. It may be, I don't know, it may be difficult to see it on some of them, but, or maybe, difficult to make sense of it, but I don't know. It's not bad. It's not bad. So here I get gamma is equal to, so when I do the inverse cosine of this, I get 110 degrees. I'm just going to round it to 110, okay? So there it is, 110. I found the largest angle. Now, it's like I said, it's not going to always be negative. You'll either get a negative or you'll get a positive. But when you use the law of cosines, it's going to let you know when you're solving this. All right, so now, which one do I need to solve for first? Do I need to solve for the smaller one that's left or the larger one that's left? Or does it matter? It doesn't matter. See, I'm going back to the law of sines now. Well, it doesn't matter. So you might be thinking, well, why doesn't it matter? Well, it doesn't matter. Is beta the largest angle? No. Is alpha the largest angle in the triangle? No. Okay, so it doesn't matter. I know both of these are in the first quadrant. So it doesn't matter which one I solve for first. I know they're in the first quadrant. So let's just go ahead and solve for alpha. So sine alpha over 9.47 is equal to sine of 110 over 21.1. So I get sine alpha is equal to 9.47 times the sine of 110 over 21.1. So sine alpha is equal to, I don't know, let me see. That's 9.47 times sine of 110 divided by 21.1. That is 0.421748299. So alpha, let's do the inverse sine of that. That is, I'm going to round it to 25 degrees. Okay. So there you go. Now we can solve for beta. So that's 180 minus 110 minus 25, and I believe that's 45 degrees. Look at that. And remember what I said. If you have to use the law of cosines first, there's no possibility of two triangles. All right. So there it is. That's law of sines, law of cosines. I don't know how many of you are still watching this. If you are, leave a comment. Let me know that you watched it till the end. All right. So I hope that helped. I hope you understand the law of sines and law of cosines first. Now. I hope you understand it now. And you don't need to memorize all that angle, side, angle, and side, angle, side, and side, side, side. That's what this one is. This one's what? Side, side, side. 3 sides. All right? So there it is. Just making these tables shows you everything you need to know to solve these things. All right, so I hope it helped. Check out my other videos. Give me a like, share, and subscribe. Thank you for watching, and I'll see you later.